Hello! Welcome back to my channel. I'm Dr. Dave Jeffrey Camposano. Our topic for the discussion today is all about transformation of trigonometric formulas. So the objective of this discussion is to classify the solutions of integrals involving the combination of sine and cosine. Okay? So combination lang muna tayo ng sine and cosine dito. So, iba pa yung sa other trigonometric identities. So, case 1, the integral of sine raised to mx cosine raised to nx dx where either m or n is a positive odd integers. So, the keyword here is either. So, kahit alin daw dun sa m or n, so meaning exponent ng sine or cosine is a positive odd integers. If we say odd integers, they are the numbers that is not divisible by 2. So ito yung identity ng gagamitin natin. This will be the identity that we are going to use. Sine squared x is equal to 1 minus cosine squared x, and cosine squared x is equal to 1 minus sine squared x. Let us try. Number 1. The integral of sine raised to 6x cosine cosine cube x dx. So how are we going to integrate this? So as you can see, wala tong direct integral dun sa formula natin. So ang gagawin natin dito is paghiwa-hiwalay lang natin siya until we can substitute this given. Okay? So the best thing to do here is to to decompose the cosine cube. Okay? So if we do that, we will be having the integral of sine raised to 6x cosine squared x cosine x dx. Okay? As you can see, I just decomposed the cosine cube x into cosine squared x and cosine xy because we are going to substitute cosine squared x by this, by 1 minus sine squared x. Okay, what will happen if we substitute that? Okay, let's see. The integral of sine raised to 6x, then cosine x, then substitute cosine squared x by 1 minus sine squared x dx. Okay? Okay, let us see what will happen. Distribute the integral of sine raised to 6x cosine x. So distribute this, no? Then the other one, distribute natin dito. So minus the integral of sine raised to 8x cosine x, then dx dx. Okay? So, what is the purpose of doing that? We all know that the derivative of sine is cosine. So, we are going to use u. Then after that, we can now integrate it. Again, let u as sine x. Then what is the derivative of sine x? Derivative of sine x is cosine x dx. Okay? If we do substitution, we will be having the integral of u raised to 6, this one, then this is our du. Okay, so minus the integral of u raised to 8 du. Okay, then after that we can now integrate u raised to 7 all over 7 minus u raised to 9 all over 9 plus c. Then of course, don't forget to substitute the original value of u, which is sine x. So we have sine raised to 7x over 7 minus sine raised to 9x over 9 plus c. This will be our final answer. Again, the technique that we use is we decompose the cosine until we have an individual cosine. Why? Because we know that the derivative of sine x is cosine x. Then after that, we can use the chain rule. Okay? So that is how we are going to do the number 1. Okay, next, number 2. So the integral of sine cube x cosine raised to 7x dx. So again, the technique is we are going to decompose. So the easiest way to decompose it is the sine. Okay? We are going to decompose the sine. We have the integral of sine squared x sine x cosine raised to 7x dx. Okay? Then substitute for sine squared x. That is, what are we going to substitute with sine squared x? 1 minus cosine squared x. That is in Pythagorean theorem, no? We have 1 minus cosine squared x multiply by sine x cosine raised to 7x dx. Okay? So multiply, distribute. The integral of, let us rearrange, cosine raised to 7x sine x dx minus the integral of cosine raised to 9x then sine x dx. Okay? Ayan. So what are we going to let u? Let u as cosine x. What is the derivative of cosine x? Derivative of cosine x is negative sine x dx. Okay? So we are going to use neutralizing factor negative 1. So for the first term natin, we will be having negative 1, the neutralizing factor. Then substitute cosine raised to 7x, then negative sine x dx. Okay? Minus, so we have the negative 1, the neutralizing factor, the integral of cosine raised to 9x, then negative sine x dx. Substitute it by u. Negative 1, the integral of u raised to 7 du plus 1, the integral of u raised to 9 du. Okay? Then we can now integrate. This is negative 1 times u raised to 8 all over 8 plus 1 u raised to 10 over 10 plus c. So for our final answer, that is negative cosine. Substitute the original value of u, which is cosine. Then negative cosine raised to 8x over 8 plus cosine raised to 10x over 10 plus c. So now this will be our answer for number 2. Okay. Okay, next, problem number 3. Last problem for case 1. Okay, so what are we going to do? We are going to decompose the integral of cosine raised to 7 2x dx. So we have cosine squared 2x. Be careful of the angle, no? The angle is 2x. Cube, then cosine 2x dx. Okay? So we have cosine raised to 6 2x, then cosine 2x. Then I change it into cosine squared. Why? Because that is the way of substitution that we have. Okay? It should be squared. So that's why I have here cube. So they are the same. This is the same with cosine raised to 6. Okay? Next, substitute. What are we going to substitute? We are going to substitute it by 1 minus sine squared. So that is 2x because the angle here is 2x. So that is 2x cube cosine 2x dx. Okay? We need to expand first. Cube. Meaning we have 1 minus sine squared 2x times 1 minus sine squared 2x times 1 minus sine squared 2x. Okay? Let us simplify. So we have 1 minus sine squared 2x minus sine squared 2x plus sine raised to 4 2x. We have if we simplify this, 1 minus 2 sine squared 2x plus sine raised to 4 2x. Okay? So this is for the first two. Then after that, we are going to multiply it again by 1 minus sine squared x. Multiply it by 1 first, all the equation in our left side. So just copy 1 minus 2 sine squared 2x plus sine raised to 4 2x. Okay? Then multiply the equation in our left side by negative sine squared x. So minus sine squared 2x plus 2 sine raised to 4 2x. So this is 2x. Okay, 2x 2x. Then the last term minus sine raised to 6 2x. Okay? Then combine similar terms. 1. Then those with exponent of 2 here and here. That is minus 3 sine squared 2x. Then those with raised to 4 here and here. So that is plus 3 sine raised to 4 2x. Then the last one minus sine raised to 6 2x. So this is the expanded form of this. Okay? Don't forget the cosine 2x. So now we are going to distribute the cosine 2x. So this is like this. Then we have cosine 2x dx. So we are going to multiply everything inside the parenthesis by cosine 2x dx. So the first one is the integral of cosine 2x dx. Okay? We are done with this. Next, this one. Remove the constant, negative 3. So, negative 3. The integral of sine squared 2x cosine 2x dx. Cosine 2x dx. Okay? Then, this one. So, plus, remove the constant 3. So, plus 3, the integral of sine raised to 4, sine raised to 4, 2x, then cosine 2x dx. Then, the last one, minus. So, minus the integral of sine raised to 6, 2x, cosine 2x dx. Okay? So we can now integrate it by letting u as letting sine 2x as our u. So let u is equal to sine 2x. What is the derivative of sine 2x? Derivative of sine 2x is 2 cosine 2x dx. So we need to use neutralizing factor 1/2. because we have an excess of 2 here. Okay, so everything will be multiplied by 1/2 except the first. Okay, underline natin isa-isa para makita natin. This is the first term, second term, third term, and the fourth term. So what is the integral of cosine 2x? Very good. The integral of cosine 2x is sine 2x over 2. So we can now integrate directly the cosine 2x because that is in our previous formula. Okay? Then minus 3. The neutralizing factor here, 1/2. Then the integral of, substitute the second equation, no? This one, second equation. So we have u squared du plus the third one, 3 times the neutralizing factor, 1/2. The integral of u raised to 4 du. Then the last one, minus the neutralizing factor, 1/2. Then the integral of u raised to 6 du. Okay? So let us now integrate. So sine 2x over 2 minus 3 over 2 u raised to 3 over 3 plus 3 over 2 u raised to 5 over 5 minus 1/2. Then we have u raised to 7 over 7, then plus c. So let us simplify. Sine 2x over 2 minus, so this is cancel, u raised to 3 over 2 minus u raised to 3 over 2. Okay, so multiply, that is 10, plus u 3u raised to 5 plus 3u raised to 5 all over the denominator, which is 2 times 5, that is 10. Then the last term, minus u raised to 7 over 14. Okay, so 2 times 7 is 14 plus c. Of course, the last step, don't forget to substitute the original value of u. What is the original value of u? Sine 2x. So for our final answer, that is sine 2x over 2 minus sine cube 2x over 2 plus 3 sine raised to 5 2x over 10 minus sine raised to 7 2x over 14 plus c. So now this will be our final answer. Again, remember in our case 1, it is stated that either m or n is a positive odd integers. So in our case 2, how about if they are both even? Okay, so this is the case 1. Okay, so for case 2, the integral of sine raised to mx cosine raised to nx dx where both m and n are positive even integers. So case 1, either add. This one are both positive even integers. So we have 3 possible substitution, right? So yan, as you can see, the angle here is being doubled. So the given is x, 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 so that is doubled. 2x, 2x, 2x. Okay? So yun lang, tandaan natin, always remember that it is doubled, the angle, no? Let us try. Number 1, the integral of cosine squared 2x dx. Okay? So as you can see, guys, we cannot use the substitution of 1 minus sine squared 2x. Why? Because we are we shall go back to the same nature of the problem because of the presence of sine squared 2x. So babalik lang tayo dun sa essence nung ano, kasi pabalik-balik lang yan, paulit-ulit lang, no? Kaya hindi pwede. So meaning, we can use the case 2. So what substitution are we going to use? This one, the first. So 1/2 quantity 1 plus cosine 2x. Okay? So we have the integral of 1/2 1 plus cosine 4x dx. Why 4x? Because the given here is 2x. So as I was saying, it should be doubled. So double natin yung 2x, it will become 4x. Okay? So now, let us remove the constant, the 1/2, outside the integral sign. So 1/2, the integral of 1 plus cosine 4x dx. Okay? So now we can integrate, distribute the dx. We have 1/2 the integral of dx plus 1/2 the integral of cosine 4x dx. Okay? So this is integrable. The first term, that is x over 2. Okay? So this, for the second term, let u is equal to 4x du is 4 dx. Neutralizing factor is 1/4. So we have plus 1/2 times 1/4, the neutralizing factor, the integral of cosine u du. Okay? Ayan, what is the integral of cosine? That is sine. Okay? So for our final answer, that is x over 2 plus what is the integral of cosine? The integral of cosine is sine. So sine 4x, because earlier our u is 4x. So sine 4x all over 2 times 4, that is 8, plus c. So now this will be our final answer. Okay? So that is how we are going to do the number 1. Okay, so problem number 2. The integral of sine raised to 4x cosine 2x, we have here dx. Okay, so how are we going to integrate this? Look at the substitution. So they are both positive even integers. So meaning, ito lang yung gagamitin natin, right? But we cannot make it as sine squared x, cosine squared x. Using the substitution of sine squared x. This is what I'm trying to say now. So sine squared x, cosine squared x. We cannot use this substitution itself kasi mas magiging complicated yung equation natin. So we can use this. How? So let me show you how are we going to use this substitution, no? Okay? So let us decompose first. This is the integral of sine squared x, cosine squared x dx. Okay? So look at this. We can rewrite it as the integral of sine squared x, sine x, cosine x squared dx. They are the same, right? Okay? So now we can use the substitution. So first, the substitution for sine squared x. So the substitution for sine squared x is the integral of 1/2. So 1/2 1 minus cosine 2x. Okay? So the angle is being double. Then the other one. What substitution are we going to use for sine x and cosine x? That is 1/2 sine 2x squared. dx. Okay? So distribute the 1/2 for the first term. We have the integral of 1/2 minus cosine 2x over 2. So I just simply distribute the 1/2. Then squared, we have sine squared 2x all over 4 dx. So ini-squared lang natin siya, no? Then after that, distribute, multiply. So the first term we have sine squared 2x over 8 dx. Okay? Then for the second term, we have minus the integral of sine squared 2x cosine 2x over 8 dx. Okay? So let us remove the fraction as constant, no, para hindi kayo malito. So we can rewrite it as 1 over 8 the integral of sine squared 2x dx. Then the other one, minus 1 over 8 the integral of sine squared 2x cosine 2x dx. So the first term, we are going to use the substitution again for the sine squared, right? How about for the second term? Is it integrable? Yes. Okay? Yes. Why? If we let u as sine 2x, what is du? Du is 2 cosine 2x dx. Okay? So this is our u. This is our du. We need to use neutralizing factor, which is 1/2. So the second term is integrable. The first term, we are going to use substitution again. So let's work out. 1 over 8 substitution. Substitution for sine squared x, that is 1/2. The integral of 1/2, then 1 minus cosine 2x. 1 minus cosine 2x. So double natin, it will become 4x kasi double na tayo dito eh. So i-double ulit natin, so it will become 4x dx minus yan 1 over 8, this one, then the neutralizing factor 1/2 the integral of let's do the substitution first. Sine squared 2x 2 cosine 2x dx. So this is for u and du. Okay? Distribute. Okay? So this is 1 times 1/2. 1 times 1/2, that is 1/2 times 1 over 8, that is 1 over 16. 1 over 16. Then the dx. Okay? Minus the same, the constant, which is 1 over 16. Then the integral of cosine 4x dx. Okay? So para hindi kayo malito, ito pwede nating we can multiply it here, no? 1 over 8 times 1/2 is 1 over 16. So this one can be 1 over 16. Then distribute the dx. So that's why we have 1 over 16 the integral of dx minus the 1 over 16 times the integral of cosine minus the integral of cosine raised to cosine 4x dx. Okay? The same as this, so minus 1 over 16 the integral of u squared du. Yan, as you can see, all of them are integrable. Right? Let's proceed with our final answer. Ito yung pinakamasarap sa lahat, yung makukuha na natin yung final answer, no? So we have, what is the integral of the first term? This one. That is x over 16. X over 16. About this one. U is 4x du 4dx and f 1/4. So we have a minus 1 over 16 times the neutralizing factor 1/4. Then what is the integral of cosine 4x? That is sine 4x. Then sine 4x. Okay? So minus 1 over 16 times u cube over 3 plus c. Then simplify for the final answer, x over 16 minus sine 4x over 64 minus u. What is our u? U is in this part. What is our u? U is sine 2x. So that is minus sine cube 2x all over 48. 16 times 3 is 48 plus c. So now, this will be our final answer. Okay? So that's how we are going to do the number 2. Okay, so last problem for case 2. Ito na rin yung last muna natin, no? Problem number 3. The integral of sine raised to 4x cosine raised to 4x dx. So what are we going to do? Substitution. So obviously, the last part, ito yung gagamitin natin, no? So let us rewrite. Sine x cosine x raised to 4 dx. Then let us do the substitution. The integral of 1/2 sine 2x raised to 4 dx. So this is, what is 1/2 raised to 4? That is 1 over 16. So let us remove the constant para mas magandang tignan, no? So we have 1 over 16. The integral of sine raised to 4 2x dx. Okay? Next, another substitution for this. Very good. The squared, right? So we can rewrite it as 1 over 16. The integral of sine squared 2x squared dx. Okay? So decomposing, let us decompose sine raised to 4 2x. It can be sine squared 2x squared. Okay? Another substitution. 1 over 16, the integral of this one. So 1/2 1 minus cosine. So this is, we are going to double here. So that is cosine 4x squared dx. Okay? So squared muna natin. 1/2 squared. This is 1/4. So we can remove the 1/4, right? It can be 1 over 16 times 1/4. Okay? Then we have the integral of 1 minus cosine 4x squared dx. So ini-squared ko muna si 1/2, inilabas ko siya 1/4. So magiging 1 over 64. 1 over 64. Then this one, squared natin. So, we are going to expand this one. 1 minus cosine 4x squared. So, let us use FOIL method. 1 over 64, the integral of 1 minus cosine 4x squared dx. Let us expand. So, that is 1 minus cosine 4x times 1 minus cosine 4x. Let us use FOIL method. So, 1 minus cosine 4x minus cosine 4x plus cosine squared 4x. So, simplify 1 minus 2 cosine 4x plus cosine squared 4x. Okay? So, rewrite. That is 1 over 64. The integral of 1 minus 2 cosine 4x plus cosine squared 4x dx. So, let us distribute the integral of 1 over 64, then distribute the dx. So, the first term, 1 over 64, the integral of dx. Okay? So, minus, we have 1 over 64 here. Okay? Then the constant 2. Then the integral of cosine 4x dx plus 1 over 64. Okay? Remember, lahat yan may 1 over 64 because we are going to distribute. The integral of cosine squared 4x dx. Okay? So, this one, this is integrable, right? Using the UDU. The first term, this is integrable, right? Check. This is also integrable using UDU. U is 4x, du is 4 dx. Okay? And f is 1/4. Okay? So, this one, it can be lowest term, no? It can be 1 over 32. So, let us exchange it by 1 over 32. 1 over 32. Then, this is also integrable. But we need to use another substitution for the cosine squared. Right? Cosine squared, this one. The last substitution, no? So, let us do it individually, slowly but surely. What is the integral of dx? That is x. So, the first term is x over 64. Okay? So, minus. We are done with this one, no? This one, 1 over 32 times 1/4, the neutralizing factor. Then, the integral of cosine 4x. What is the integral of cosine 4x? That is sine 4x. Okay? Plus, so if we simplify this, that is sine 4x over 128. So, let us replace it by this one para mas madaling tignan, no? So, minus sine 4x over 128 plus, okay, this one plus 1 over 64. The integral of what substitution are we going to use for cosine squared? Ayan, so 1/2. We can remove the 1/2, the constant 1/2, no? We can bring it outside the integral. So, 1/2. This is the 1/2. The integral of, so what substitution? 1 plus cosine 2x. 1 plus cosine 2x. So, double. It will become 8x. Don't forget that, ha? Double natin. So, cosine 4x, it will become 8x. Kasi do-double natin, no? So, 1 plus cosine 8x. Then, dx. So, ang problema lang natin dyan is the last part. The first two are already integrated, right? So, x over 64 minus sine 4x over 128 plus 1 over 128, the integral of 1 plus cosine 8x dx. So, distribute the dx. X over 64 minus sine 4x over 128 plus 1 over 128, the integral of dx, plus 1 over 128, the integral of cosine 8x dx. So this is integrable, this is integrable, right? So yan, we can now arrive with our final answer. So let u is equal to 8x du 8 dx. Then nf is 1 over 8. So x over 64 minus sine 4x over 8, 128, plus the integral of dx, that is x over 128 plus yan, no? So 128, 1 over 128 times the neutralizing factor, which is 1 over 8, then the integral of cosine 8x. What is the integral of cosine 8x? That is sine 8x. So what is 128 times 8? That is 1024. So plus 1 over 1024, then the derivative of, or the integral of cosine 8x is sine 8x. Sine 8x. So we can rewrite this as sine 8x sine 8x all over 1024 plus c. Okay? But this one, we can simplify this using the LCD because they are the same, right? So the LCD of it is 128. So as you can see, x over 64 plus x over 128. What is the LCD? LCD is 128. What are we going to do with the LCD? Divided by each denominator, then multiply by numerator. So this one will become 2x plus x over 128. So 128 divided by 64, 2 times x, 2x plus, so 128 divided by 128, 1 times x, x. So that is 3x over 128. So we have 3x over 128 minus sine 4x over 128 plus sine 8x over 1024 plus c. So now, this will be our final answer. Okay? So kung mapapansin nyo, mahaba yung procedure pero madali lang. Just repeat the process, no? Okay? So that's how we are going to use transformation by trigonometric formulas. So yan is applicable, ginagamit natin siya sa sine and cosine. Iba pa rin yung sa tangent and secant, no? Pero at least na-encounter natin kung paano siya gagawin. Para yung sa mga susunod, alam nyo na rin kung paano siya gagawin. Kasi same procedure lang naman siya, substitution, decompose, then substitute, then integrate. Okay? So that's all for our discussion for today. I hope you learned something new. So that's all. Thank you. Have a nice day. Keep safe everyone. Bye-bye.